All right, welcome. So before we move on to some other functions from the apply family, I want to take a look at a few more examples with the apply function. We haven't applied this to three-dimensional arrays, for example, and we haven't really thought about what happens when we have more complicated functions than, say, the mean function that require some additional arguments in them. So let's consider this same matrix that we created earlier, MAT, which is this 5 by 2 matrix. And let's say we want to go ahead and calculate the 50th percentile for each column of A. So what we can do is, okay, or excuse me, of matrix MAT. So our data is going to be MAT, is stored in MAT. So I don't need to type the name of the argument and type X equals MAT, dimension equals to, we can hide, we don't need to use the name of the argument, and that will make the code maybe a little bit more concise. So I can enter the data frame matrix or array that I want to apply this function to. So that's MAT. We want to calculate the median and we want to apply this to each column. So that is dimension 2. And to find the 50th percentile, I can use the median function. We did that earlier, but I want to illustrate how we can enter a function that requires some additional arguments. So we can also use the quantile function to compute quantiles, and the median is the 50th percentile, or it's the 0.5 quantile. So how the quantile function works is we enter a vector that we want to calculate the quantile of, and then we need to indicate a probability amount that we want for the quantile. So here we're going to set the prob argument equal to 0.5. And that's going to calculate the 50th percentile of each column of this matrix. So we'll run that. So if you have some additional arguments that you need to input into your function, after you name the function, you put a comma, and then you can just list out each of the arguments that you want to enter into the function. So it's going to assume whatever comes after that comma are going to be arguments that we input into that function. Okay, we can apply the apply function to higher dimensional arrays. So in this code cell, I'm going to create a three-dimensional array. The values in the array are going to be the integers from 1 to 24. And we're going to set up our array to have 3 rows, 2 columns, and then 4 kind of slices in the third dimension. So each of our dimensions is going to contain a 3 by 2 matrix, and we're going to have 4 3 by 2 matrices. So I'll run this code cell, and we can take a look at the array that was generated. So the first matrix has the first 6 integers. Then in slice number 2, we have a 3 by 2 matrix that has integers 7 through 12, and so on. And then the final slice, the final third dimension, is a 3 by 2 matrix with the integers 19 through 24 arranged. So now if I want to, say, calculate the mean for each row of A, let's see what happens. So the data that I want to apply the function to is stored in array A. I want to apply this function mean to each row. So row is dimension 1. So that's why I have these 3 inputs. A is the data structure, 1 is the dimension, mean is the function that I chose, and that does not require any additional argument. So I'll run this, and we get 3 results because we have 3 rows, right? So we have 3 rows in our array. So let's think about what happened here. What didn't happen is it didn't calculate the mean of values 1 and 4 across the first row of the first slice. But what it does is it wants to calculate the mean value of all of the entries in row 1. So in the first slice, we had entries 1 and 4 in row 1. And then it's going to go into the next slice and say there was row 1 over here that had values 7 and 10. 13 and 16 were the first row of the third slice. And then the fourth slice had 19 and 22. So it's going to take all of those values that I just named, all of the values that sit in row 1 someplace in this array. There's 8 of them because we have 2 values for each of the 4 slices. So we add up all of those values, we average them, divide it by 8, and that's where the 11.5 comes from. And you can similarly get the 12.5 and the 13.5 by taking the 8 values that are being stored in row 2 from each of the slices and averaging them out. And then we take the 8 values that are stored in row 3 of each slice, add them together, divide by 8. That's where the 13.5 comes from. We could have calculated the means of each rows by indexing and using the mean function because the mean is a vectorized function. So if I enter A and then in square braces here, square brackets, excuse me, I enter 1 and then blank for dimension 2 and blank for dimension 3, that is going to extract all of the values in row 1, and then I can apply the mean to that value, and that's going to give me the 11.5. And I could calculate the mean of row 2, and I can calculate the mean of row 3 using this. But what's really nice about the apply function is it does all 3 of those in one shot in a really concise way. We could also apply functions across the third dimension of an array. So in this case, the function that we're going to apply is the sum function. And this dimension being set equals 3 means we're going to calculate the sum of the values in each kind of slice across the dimension 3. So it's going to take this first slice, this first 3x2 matrix, add all of those values together, and that's where the 21 comes from. Then it's going to take this slice over here, add all these values together, and that is where 57 comes from. And then the 93 comes from adding up all of the values in the third slice in dimension 3, and then we add up all of the values in the fourth slice of dimension 3. So what we get back is a vector that contains 4 values. Each value is the sum of all of the entries in one of the slices of dimension 3. And again, we could do that similarly by indexing and using a sum function, but then we would need to do this 4 separate times. And the apply function, we get all of those outputs in one shot. We can apply the mean function in this case, in this code cell, across multiple dimensions. So here, if I choose as my dimension 1:2, this means all of the dimensions that start at 1, including 1, up to and including 2. So let's kind of check the output here. We get a matrix. We get a 3x2 matrix here. And this first value 10 that occurs in our result, this 3x2 matrix, it is corresponding to the following thing. So I have my array A over here, and now we're going to apply the mean function across the rows and columns. So let's take a look at row 1, column 1. That is the numbers 1, 7, 13, and 19. So it's going to average 1, 7, 13, 19. Those average out to 10. And why we're averaging them, that was the function that we chose over here. We chose the mean function. So that is what value we place in row 1, column 1. Then we go over to row 1, column 2. The output is telling us 13, and that 13 comes from taking the average of the 4 entries in position 1, 2. So that's the 4, the 10, the 16, and the 22. We add them up, we divide by 4, that gives us 13. And then we do the same for each of the other rows and columns. And that output is now stored in a matrix. So the output that we get from the apply function, again, we've been getting vectors back because we've been getting one-dimensional results. In this case, we had a two-dimensional result, which was being stored in a matrix. And we could have calculated this value 10 using indexing. For example, if I wanted to calculate the mean of all of the values in row 1, column 1 across the third dimension, then I could set row index equal to 1, column index equal to 1, leave this third dimension blank. So that's going to pull off the 4 values in position 1, 1, and then average them together to get the mean. But if I wanted to get the output from this apply function, I would need to run this 6 times and then store the output in a matrix. So the apply function is a really, really nice and concise way to apply the same function over and over again to some data object. Okay, so that is a wrap on the apply function. We'll next take a look at the lapply function.